So we're back in the shop, and I'm sort of depressed about my non-functioning, or I couldn't get it to function, lathe turret. Tormach's closed until I think Tuesday. It's New Year's. So we're going to go ahead and start on the plasma table, router table, whatever we want to make it into. I've got some thoughts about welding with it and doing whatever, basically just making a big lower tolerance mill, I guess. So I started out with a kit from Precision Plasma. I bought it probably been 2 years now at this point, but I am making some changes to that kit, partially because of some stuff that I ordered that I wasn't paying attention enough and got damaged. The drive section is a C and CNC ether. It's like an Ethernet controlled drive. It runs basically an Ethernet line to the computer. I'll post a little bit of info in the middle of this about those. So I've got the heaviest gantry that Precision Plasma sells, and we've got, this is it sort of put together. I had to do a little mock-up to get an idea of what of the modification we're going to make here. So essentially, it's built kind of with tab construction. All these pieces come in the kit from Precision Plasma, not this piece. This comes with the motor drivers. So this is basically your sides, and then your gantry goes across here. You get another plate that welds onto the side. So the way they have it set up, you use these rollers, and let's see if we can get a good angle on this thing. Originally, you're supposed to use a piece of cold rolled steel here, and then basically it just runs with a roller on a couple different surfaces, and that's what positions it as it moves. Part of the problem was I ordered two of these things. This is a 5x10 table that I'm building, and so it's basically 12 feet long with the extra for the gantry. So I ordered these two pieces. I think they were about, I want to say they were about 225 bucks from local steel supplier for that cold rolled, and I got it back here, and they were both the same together, but when you flip them, like kind of book match them, whatever, kind of lay them down flat, they were out about, I think about 3/16 each in the middle, and I think it's from they just picked it up with the crane and bent them. You know, I probably could go back and complain about it, but it's kind of not worth the hassle. So that's what slowed me down. I let this thing sit here for a while with all the pieces already sort of cut, I'm coming back around to working on it. I bought the mill and the lathe and all this other stuff, so working on getting this project finished. So instead of going with this, what I think is probably a less tunable solution anyway, where you're basically welding this to this, oh, I shouldn't set that on top of there, to the top of this rectangle piece, and then welding that to the top of here. You can't really fine tune it. I mean, it's meant to be a plasma table, so torch height control and other features of that can easily compensate for it. And if you're not making big pieces, you're not going to notice the tolerance being out. I mean, if you're trying to cut a straight piece that's 10 feet long, then yeah, you're gonna notice it. But most things you're cutting in this type of scenario aren't going to be like that. But I'd rather just fix it. So I ordered these linear rails. These are a 25 millimeter. I think they're. So basically, you've got these carriages that run on top of these. This is a 25 millimeter. I believe that's the width. I'll put up a little schematic of what we're working with here. And I've got 4 of these carriers. So essentially I'm going to replace the wheels in that with the carriers, take out this section, and then I just need to screw these to the top of this tube here, and then we'll run our teeth will still be, I think that welds to the top of here. I'm trying to remember. Even this stuff I ordered a couple months ago, so it's, you know, whatever. I work on one project and then go away and do something else and come back to it and try to remember what I was doing. So I think this sits on top of here. Actually, let me take a second and just mock this thing up, and we'll come back to this. Okay, so here's basically what we're going for. This is these are, I think it's called Hiwin is the brand. I got these from a company called Motion Constrained out of Colorado. No complaints. It was free shipping. These are, just for comparison before I forget, this is about $1,000 for all. I got 4 carriages and then 4 sections that was enough to cover 12 feet. It's a little bit long, versus the if I hadn't spent the $225 or whatever for the cold rolled already, it wouldn't really be that bad for the huge upgrades you get in precision. So, and again, plasma, it probably wouldn't matter, but I want to be able to do whatever I want with this thing. You can get them with different wipers. So if you've got spatter that gets on the rails, I may do something with an accordion thing or something to cover that once we get this more assembled. But they do make where you can take this end off and get a scraper that will clear that. It does have a seal in here, and then you can replace this with a greasable fitting. So these are high quality. I saw these guys at IMTS. They've got this company Hiwin. They sell a bunch of stuff. I'm not huge into linear rails as far as being a connoisseur of them and telling you whether these are great or not, but they seem to be pretty good. So what we're going for is, we've got the precision plasma kit, which came with this rail here, and then this is all the precision plasma parts sort of mocked up. I do have the motor in there just for extra, so that doesn't come with the precision plasma kit. But this is sort of precarious, so let me see. Get the camera where I can see it. So the idea is that needs to engage with those teeth there, which we're a bit high of, but there's plenty. The main thing I had this together for was to measure that between that carriage there, that I can cut that edge and raise it up to the point. The only constraint you have there is that the top of that rail can't hit the motor, which is in there. So the distance from the bottom of the motor to the top of that rail from where we're sitting right now has to be greater than the distance we need to move down in order to have the teeth engage there, which it is. So I'll just have to, once we get this all welded up, modify this edge so that there'll be a new mounting plate that lowers the gantry so that the teeth will engage. And you do have a little bit of adjustment there with that side. So, but that's the basic idea. So the next step is that we're going to drill and tap this tube. I believe it's a 2" by 1.5" tube. We're going to drill and tap that so that we can mount the linear rail to that. I've got a 4" tube that I'm actually going to build this on top of. That's not what they call for in the precision plasma plans. But I was trying to get away with only doing 2 legs at the end. The initial idea was to mount this in the garage a different direction. Get this out of here. I was going to, I don't have my wide enough lens on here. So I was going to run this side to side in the garage, and I wanted to be able to store sheets underneath it. And my plan was to come in with the tractor and be able to pick sheets up from underneath it and set them on top of the table. Well, now I've got this gantry hoist that I bought for moving the lathe and the mill. Now that I've got that, I'm going to run it the other direction. So if I've already got the steel cut, so I might as well just use it the way it is, but I may put legs in the middle of it and not just do 2 at the end just to give it a little more strength. But with the water table, it's a fair bit of weight, and being able to set basically whatever I want on it. But that's the idea, is that we're going to have this thing sitting here and then have the gantry over it and be able to load it with the gantry if we have something heavy. I may modify or make like a track for the gantry to fit in. So you've got a fixed, track going up and down the side, and then instead of putting these caster wheels on it, put a fixed wheel so that I can slide it, because it's sort of a pain in the butt to move one side and then go around to the other side and then move it back. So that I think that's going to work pretty well. But now we'll get really the first step here is we're going to get set up to drill and tap these holes on the Tormach mill.